Previously, we looked at the Laplace transform of a piecewise function where f of t was either 0 or t minus 2. It was 0 on the domain of 0 to 2 and was t minus 2 on the domain of 2 to infinity. Let's continue this with another example. Here is example number 2. And in this case, f of t is going to be a piecewise function. So the function is either 0 on the domain 0 to 3. It is 1 over 3t plus 2 on the domain 3 to 6, and it is 6 on the domain 6 to infinity. So you may graph this function. I'm going to have my horizontal axis as the t-axis, my vertical axis as the f of t axis, and I'm going to indicate 0, 3, and 6 on my horizontal t-axis arbitrarily, but in their respective correct positions. And I'm going to graph the entire function f of t in red, all three pieces in red. So the first piece is 0 from 0 to 3. The second piece is 1 over 3t plus 2 from 3 to 6. And finally, at t equals 6 and after t equals 6. So for the values of t greater than or equal to 6, the function is a 6. Might start up here, and then it will be a flat line. And I will complete the graph with the associated y values at each of those endpoints. So the left endpoint for this line, 1 over 3t plus 2, is going to be 4, whereas the right endpoint, I'm mistaken, the left endpoint for the line 1 over 3t plus 2 is going to be 3, and the right endpoint for the same line is going to be 4. And the last piece, y equals 6, trivially starts at 6 on the y-axis. However, it does not start until the value of t is 6. So, given us the graph of our function f of t, now, as we did previously, the first thing is to write f of t using unit step functions, and again, you would treat each of these three pieces as signals. Treat the left endpoint of the domain as the starting point and the right endpoint of the domain as the stopping point for the signal. So this time I'm not going to write the signal with 0 because it makes no difference. We will start therefore with the second signal, or the second piece of the function, which is 1 over 3t plus 2. So therefore we can say f of t is equal to this first piece, 1 over 3t plus 2, which starts at 3, and so I must attach a u3 with it. And now the same function 1 over 3t plus 2 stops when t value is 6, so I will attach a u6 with it. And because it stops, I have to subtract it. So whenever you start, it is positive. Whenever you stop, it is negative. And then finally, the third piece is a constant 6 It starts at 6, so I have to attach u6 to it, and it never stops, so I never have to subtract it. And therefore, here is the full description of our function f of t using unit step functions. Now we must make appropriate variable changes. So first of all, remember that tau needs to replace the t in each of these terms. And because we have 1 over 3 t plus 2 attached with two different unit step functions, u3 and u6, I'm going to evaluate each one of those two separately. So let's first look at 1 over 3 t plus 2 u3. So this implies that tau must be t minus 3. Tau is always t minus the subscript on the unit step function. And so that implies that t is going to be tau plus 3. And so when we make this substitution into our function, 1 over 3t plus 2 u3 will simplify to tau u3 plus 3 u3. And therefore, let's go ahead and take the Laplace transform. So the Laplace transform of 1 over 3 t plus 2 u3 is the same as taking the Laplace transform of tau u3 plus 3 u3. And so remember, the Laplace transform of tau is 1 over s squared. u3 brings in e to the negative 3s plus the Laplace transform of 3u3 is 3 over s e to the negative 3s. And for these two Laplace transforms, you may refer to the list of transforms. How the Laplace transform of tau is 1 over s squared, and how the Laplace transform of 3 is 3 over s. So this e to the negative 3s is attached to both of these two simply because of the presence of this u3. In the same way, let's look at the Laplace transform of 1 over 3t plus 2 u6. In this case, because we have u6, tau is going to be t minus 6, which implies that t will be tau plus 6. And this further implies that 1 over 3 t plus 2 u6 is going to equal tau u6 plus 4 u6 when simplified. And therefore, we may take the Laplace transform of 1 over 3t plus 2 u6, which is the same as taking the Laplace transform of tau u6 plus 4 u6. Again, remember the Laplace transform of tau, you can get that from the list of from the list of transforms. And so from the list of transforms, the Laplace transform of tau raised to 1, is 1 over s squared. The u6 brings in e to the negative 6s, plus the Laplace transform of a constant. The Laplace transform in this case of 4 is 4 over s, and the u6 brings in e to the negative 6s. And therefore now we can take the Laplace transform of our original function. So the Laplace transform of our function f of t is going to be the Laplace transform of each of the three pieces taken individually and added together. So it is the Laplace transform of 1 over 3t plus 2 u3 minus the Laplace transform of 1 over 3t plus 2 u6 plus the Laplace transform of 6 u6. And therefore we can simplify this to the Laplace transform of f of t is going to equal the Laplace transform of the first piece, 1 over 3t plus 2u3, which we evaluated to be 1 over s squared, e to the negative 3s, plus 3 over s, e to the negative 3s, minus the Laplace transform of the second piece, which is also evaluated. However, remember that you are subtracting, so we have to subtract each term in the Laplace transform of 1 over 3t plus 2u6. In other words, negate both the terms in that Laplace transform. So therefore, we will have negative, or should I say minus, 1 over s squared e to the negative 6s minus 4 over s e to the negative 6s. And finally, the Laplace transform of 6u6, which is 6 over s e to the negative 6s. Now at this point we may leave the transform as it is. There is only one final simplification that may be done, which is if you look at the last two terms, they're both alike and they can both be combined into a single term, which would be positive 2 over s e to the negative 6s. And therefore, this is the Laplace transform of this three-piece piecewise function.